Hey everyone, welcome back. Today, we're jumping straight into an explainer on a really high-stakes audit of clinical trial mechanics. Whenever we look at medical data, we're basically watching this epic battle unfold between real-world truth and ideal-world theory. So we're going to dissect exactly how researchers manage the incredibly messy reality of human patients and how the choices they make can literally alter whether a new medical treatment is considered a massive success or total failure. Let's get into it. So let me hit you with the ultimate hook question. What happens when a huge chunk of patients, say 30% of them, just flat out quit a clinical trial? Do we just ignore them, count them as failures? Do we pretend they never even existed? This right here sets up a massive courtroom-style drama over missing data and high dropout rates. And how we answer this question fundamentally changes medical history, because it literally dictates whether a drug gets approved for all of us or thrown straight into the trash. To guide us through this audit, we've got a golden rule. It's basically our mantra for the day. Once randomized, always analyzed. I want you to repeat that in your head until it becomes an absolute earworm. Once randomized, always analyzed. This phrase is the absolute bedrock of reliable, unbiased clinical data. And by the end of this, you're going to see exactly why it is so heavily defended by regulatory boards. Section 1, the clinical trial dilemma. Okay, picture this. We have a randomized trial for a brand new oral medication for multiple sclerosis. Investigators enroll 200 patients, splitting them perfectly evenly. 100 get the drug, 100 get the placebo. But in the drug arm, 30 of those 100 patients drop out completely because the drug causes severe abdominal pain. Meanwhile, in the placebo arm, only 5 patients drop out, just due to losing touch for follow-ups. So, here is our dilemma, right? If we're trying to prove whether this MS drug actually works, what on earth do we do with the data from those 30 people who simply couldn't handle the treatment? Section 2, the adherence purist, per protocol. Well, one approach is the per protocol analysis, and it is exactly what it sounds like. It acts as a diagnostic dividing line that evaluates strictly the subset of subjects who followed all the rules to the letter. If a patient missed a dose, if they crossed over to the placebo group, or if they dropped out because of brutal side effects, like our 30 MS patients did, boom, they are entirely excluded from the final data. This method essentially measures ideal world efficacy. It's asking, hey, does this drug work under perfect, laboratory-like biological conditions? But wait, there is a fatal flaw here. By just deleting the dropouts, the per-protocol approach introduces a massive, massive problem called attrition bias. And that's a form of selection bias. Why is this so incredibly dangerous? Well, because the patients who can actually tolerate a drug and stick to a strict schedule are fundamentally different from the ones who drop out. That remaining group, they might be healthier overall, maybe more highly motivated, or they just have fewer underlying health issues. So high dropout rates lead directly to this attrition bias, totally distorting the real relationship between the exposure and the outcome. Relying on a per-protocol analysis to claim a drug is superior for the general public is honestly a huge, dumb mistake. By looking only at the subjects who perfectly completed the trial, our external validity just plummets. We end up creating this artificial environment that doesn't reflect the real world at all. Section 3, the randomization guard, intention to treat. This is where intention to treat, or ITT, steps in to save the day. The crucial thing to remember is that ITT evaluates everyone based on their initial assignment. It literally doesn't care if a participant dropped out. It doesn't care if they crossed over to the other treatment. And it doesn't even care if they flat out refused to take a single pill. They are analyzed exactly where they were randomized on day 1. Remember, once randomized, always analyzed. Let's break down why regulatory boards consider this the absolute gold standard. Its core purpose is preserving the power of randomization. You see, randomization is brilliant because it evenly distributes all those known and unknown confounders between the groups right at baseline. Excluding dropouts, that destroys that delicate prognostic balance. Plus, ITT measures true clinical effectiveness. It measures how well a drug actually performs in clinical practice, out in the real world, where missed doses, horrible side effects, and human error are just a guaranteed reality. It all brilliantly illustrates the dichotomy between the two philosophies. Per protocol gives us ideal world efficacy. It's trying to capture a pure laboratory signal with all the noise of unpredictable human behavior. But intention to treat gives us real world effectiveness. And here is the real secret. Those dropouts, they aren't just noise. They are high signal data reflecting drug intolerability. Erasing them just creates a totally false narrative.
Section 4. The Compliance Drill, Clinical Vignettes.
Let's bring it back to our MS trial and watch how the numbers shift depending on the analysis. If researchers delete the dropouts in a per-protocol execution, they are only comparing the 70 perfectly adherent drug patients against the 95 placebo patients who finished. Surprise, surprise, the drug looks absolutely incredible, showing a massive reduction in MS relapses. But let's be real, this is highly biased. It vastly overestimates the drug's benefit because it completely ignores the 30 patients who literally couldn't stomach it. So the secret sauce to intention to treat relies on fixed denominators. Because you started with 100 patients in the MS treatment group, ITT point blank refuses to shrink that denominator, even if 30 of them bail out. The dropouts are retained, usually they're just assigned a failure or no change outcome, and the math remains totally anchored to the reality of the starting sample size.
Section 5. The Final Verdict, the Executional Pearl.
Let's trace the logic gap of why ITT is so highly respected, especially on medical boards. Because intention to treat stubbornly retains those non-compliant patients and dropouts in the treatment group, it naturally dilutes the difference between the experimental group and the control group. It waters down the experimental effect. And because of this dilution, it mathematically shifts the final outcome directly toward the null hypothesis. Now, for measures of association like relative risk or odds ratios, the null hypothesis is 1.0. A value of 1.0 means there is absolutely positively no difference between the drug and the placebo. By constantly pulling the data towards this number, intention to treat makes it much harder for researchers to actually prove their drug works. It is literally the most brutally conservative test in all of statistics. Which leads us to conclude this explainer with one final thought for you to chew on. If a clinical trial is subjected to the strict, conservative, mathematically diluted gauntlet of intention to treat, and it still manages to demonstrate a statistically significant benefit, well, isn't that the ultimate proof of the drug's power? Surviving ITT means a treatment isn't just some fragile laboratory theory. It's a robust, real-world solution. Thanks so much for joining me on this audit, and keep questioning the data.